In this video, I will explain what is Bridgeport and why is it valuable. My name is Ty Everett, the founding president of Project Babbage and the creator of Bridgeport. Let's get started. In order to talk about Bridgeport, we have to talk about Babbage a little bit. So just a 50,000-foot view for those who don't already know. App developers in Babbage enable users to take actions and interact with the world. The actions taken by users are private and only accessible to those involved. Actions stay with users across all of the different apps and websites they use to give them a more personalized web. Based on the past actions of users and the current state of the system, app developers synthesize a good experience for their users. Every action has a small cost, and the proceeds go to the app developers, rewarding them when people choose their apps in order to make their actions over any competitors. Finally, since actions belong to users, they are free to use any suitable apps to access their personal data and own their identity in the digital world. So Bridgeport is mainly focused here. Based on the past actions of users and the current state of the system, app developers synthesize a good experience for their users. So in order to do that, app developers are going to take into account whatever actions taken by this and other users they think are most relevant in the current context of whatever their app is, in order to provide a good experience for the users of their app. So every app developer is free to interpret the actions it thinks are relevant of any users who are, involved and who have granted access in order to give the current user whatever that app developer thinks is a good experience. So the app developers need a way to track the actions that have been taken by this and other users, derive the current state of the system that they want to use in order to present those actions in a good user experience, and then provide that experience and synthesize it out through a user interface in order to interface with their users in such a way that they think is best. And in so doing, of course, this is with the hope that the app developer can receive the small costs associated with the actions that were taken by users, because the app developer hopes that providing this good experience is going to make the users choose their app over their competitors. This is, of course, without data silos or anything like that. So that's the role of Bridgeport. Its main focus is in kind of aggregating together the actions of users. So let's move on to tracking user actions. Actions are registered on the Bitcoin blockchain. So that just means that when a user creates an action with a Babbage app, it's going to register the action on the Bitcoin blockchain. Bridges receive incoming actions from users. So as the app developer, when you enable a user to take an action, you're also going to send that action into the Bridgeport bridges that you deem relevant, which means that the bridges that you're using to derive the state of the system, which is being then further presented later on to create a user interface for your users, those bridges are going to receive all actions from your users. And as we'll see in a second here, it's also going to receive any other relevant actions that come from other users, even if they don't use your app, so that it can derive the state from the blockchain. Transformers derive state from actions. So your bridge is going to, whatever bridge you're using is going to transform the actions that are incoming from users from Bitcoin format into instructions which create a state. So a database table or some other method of tracking state based on the actions that happened, from which users they came and in which order they came, as prescribed by the Bitcoin blockchain. Readers serve the current state to clients. So whatever the current state is, you're going to, the bridge reader is going to give and make available the current state to clients in such a format. So basically like an HTTP, read-only API to, allow you to create a UI and a good user experience for the people using your applications. And Bridgeport sends all processed actions to all nodes. So that means if you're running a bridge on Bridgeport that takes into account certain actions, once those actions have been processed and kind of validated by the bridge that you're using, the Bridgeport node is also going to make it so that anybody else using that same bridge, anybody else wanting to interpret these actions in the same way or using the same protocol or in the way that would allow them to be presented, would be able to derive and arrive at the same state that you arrive at based on what is in the blockchain, based on the actions that were taken by the users, which are, of course, Bitcoin transactions. So let's talk about some of the benefits of doing it this way. It's easy to verify that bridges are serving the correct state. So given the bridge, so the code and the methods by which that bridge derives state from the blockchain, and given the actions that were put into that bridge, which are served and broadcast to all nodes who host that bridge, we can easily determine whether or not a given node or a given bridge is acting as it should and serving the state that it should based on the things that are in the blockchain at that time. And it's secured by the immutability of the blockchain. So the fact that transactions in the blockchain are in a certain order means that there's no wiggle room per se, for once things are confirmed in a block, what the current state should be. Everybody always is going to be on the same page because everybody always is going to derive state in the same way. And it's redundant against server and network failures. That's because there can be multiple nodes that run the same bridge, and those nodes can be independent of one another from a network and server perspective. So if one of them goes down, there's no need for clients to just give an error. They can move to other nodes that have the same exact information. And because it's derived in the same way, the responses from all nodes that host the same bridge are going to be identical. It is scalable to thousands or probably even millions of instances in parallel. And that's because, for the same reason it's redundant, we derive the actions from the blockchain, and we use those actions to construct a state, and that state is held in parallel. And that means that we can basically just have certain clients contact certain nodes or randomly select, and we'll end up with a way of having this replicated availability across different systems that automatically are coordinated and synchronized by the nature of the blockchain and the derivation of the actions therefrom. It's private by default with users in control of data. And that's the final thing here. Because of the way that Babbage generally works, actions contain encrypted payloads that are accessible only to those involved. They're controlled by keys held client-side, so there's no single crunchy shell or master key, so to speak, that holds everything. Data, depending on the way that you construct your protocol, is held by the people involved. And you can derive state from that, but the encrypted payloads can simply be served by the bridge readers in such a way that data is only accessible to those who need it. So not really any big chance of an enormous data breach or anything like that. So that's Bridgeport. That's why it's valuable. And if you're interested in building with it, you should get some developers together, and you should look at how to build with Bridgeport. So check out some articles and videos on my YouTube channel, the Project Babbage YouTube channel, or you can check out projectbabbage.com, where there's some great tools and resources that you can reference to start creating Bridgeport bridges and build backends on Bitcoin. So thank you very much.